Welcome and hello. This is a video lesson in WRIMS, and in this lesson I'm going to be talking about future variables or array variables. Sometimes they're called future array variables. But basically what it is described in the Russell Plus reference manual right here. Future array statements can simplify coding for multi-period optimizations using arrays. So basically what we've done so far is we have had decision variables and state variables and constraints in a single dimension. However, if we wanted to create an array of state variables, decision variables, and constraints or goal statements, then we can do that by creating an array and then referencing the index of that array for whichever index of the array we want to reference. So I'm going to go ahead and show you basically what we've done and then how this future array statements work with decision variables and then further down state variables and constraints. Okay, I'm going to bring up a quick model schematic here. Nothing too crazy. We have inflow into a reservoir. So inflow is I_1. Storage in the reservoir, I'm just going to call S_res1. And then we have downstream channel flow between nodes 1 and 2, C12, and then a downstream demand here at node 2, represented by the variable D_2. If I bring up the Russell Plus, right here, this is my channels file, channels.russell. And what I'm doing is I'm defining a decision variable right here for my channel 1, 2. Now we've seen this before. This is just a simple way to define a decision variable. But if we're using arrays, future arrays, this is the particular format that you use. It's still dvar. And then in parentheses, the size of the array, space, the name of the decision variable, open brace, and then open bracket, and then everything else you would have inside a normal decision variable. So all the different types of decision variables like continuous, bounded, integer, and binary, those are all fair game. And the reference manual here shows a couple examples. So for instance, dvar11 will create 11, or actually it's a size 12 array because it's going to go from 0 up to 11. The variable name is C delta SWP, and then after that will be appended __ fut number, FUT for future, I believe. So it doesn't have to be future. You can use the indexes of the array for, anything you want that dimension to represent. It doesn't have to be time. But I'm going to go ahead and just do an example here. So if I wanted to add a future array or just an array in general, I'm going to put a parentheses 3 right here after the keyword dvar. And what that means is we now have an array of dvar with this specific variable C12. So the flow through channel C12 now has a index array 0, 1, 2, and 3. So it's actually size 4. Whatever value you put in here, that's the maximum index, but the counting starts at 0. Everything else here looks pretty much the same as far as what you've already learned about decision variables. You can have a standard, which is unbounded. Well, I mean, it's non-negative. And then you can have the bounded type with a lower and upper limits. There's binary and there's integer. In my main Russell file, the only file that's not commented out here is that channels file. A little bit later in the lesson, I'm going to add a few of these other files just to give a few different examples. But for now, we're just going to define the decision variable and then run the model. So I'm going to go up to my RIMS and then right click on the launch file. So that ran. Over here, this is my decision variable file, db.dss. So let's go ahead and see what we have here. View, refresh catalog. Okay, so I lied. We actually have 5 variables. Now, the 4 variables that are in the array are these ones right here, but it did also give us a C12 without the suffix of FUT0, FUT1, 2, and 3. So these 4 belong to the array. Okay. At this moment, there's no data assigned to them, so it's just generic. It's default, it's 0. Further down in the reference manual, we hear about state variables. So state variables are a similar situation. What's different about state variables is that it uses this $M symbol to represent which index of the array that is being defined. So this first example here, svar, this is just a simple state variable, which we saw in a previous lesson. It's a single value, and it's being assigned to 23. Now that 23 is being used the next line down to create the size of the WY date variable. So this is probably water year, and we're going to be defining 24 water years, or it looks like we're creating a state variable wy, that's going to be sized 24. And then this m iterator is actually divided by 12. So I think what's going to happen is we're going to basically have two different water years represented 1 month at a time. We'll go ahead and do this example a little bit later. Let's do a simpler example. I'm going to bring up the inflows file right now. So what I'm doing here in this very simple example is we're defining an array of size 4 with using index 3. It is I_1 representing the inflow into our reservoir, and I'm setting the value equal to m. Now I could just set this equal to a constant like 4 or 100 or whatever, but if I set it equal to m, we can see what that value looks like. So here's the inflows, here's the channels. We're going to focus on inflows though. So I'm going to open that up and then come down here to right click on the launch file, debug. I already have it stopping after the first month of a 12-month simulation. So boom, it paused right here. And over here to the right, we can see the different variable values. So I_1 representing I10, that has a value of 0. And then 1, 2, and 3 have inflows of 1, 2, and 3. All right, let's do something a little bit more involved. For the inflows, instead of just equal to that particular index, we can do something like this. So it's the index times 2 plus 1. So if the index is 0, the value is 1. If the index is 2, the value would be 5. So we'll just go ahead and see that in action. Right click and debug. Okay, that's updated. 1, 3, 5, and 7. You see over here in the all variables panel where I'm tracking the variable values. Up above, we just have the decision variables for our channel 1, 2. Those are all 0. We're not actually running an optimization. We're just defining the variables right now. Okay. One final example here is right here. This is the example from the reference manual. So we have reserved variables month, which ranges from 1 to 12, 1 being October, and then here's our iterator, 1. We're dividing that by 12. And then here's another reserved variable in the Russell Plus language, which is water year. So let's go ahead and see this in action. And then let's run that. So right click, debug. So right now it's returning 1922 because we're only in the first time step, or sorry, the first month. I'm going to go ahead and change this to towards the end of the simulation. So how about like the last month? And then I'll click play to advance. All right, so now we have 1922, 1923, 1923, and 1923. So these input values, these state variables, are changing over the course of the simulation. Okay, back to my inflow file. This right here is still technically a simple state variable in how it's defined. But what I'm going to paste in now is a inflow file that's referencing data from a file, a .table file, specifically this inflow_data.table. That's a file saved in the lookup directory. And then what I want to retrieve is the inflow column, the data from the inflow field from that table, and then where the ID, I'm creating an ID that's a combination of the month and the index. So I'm multiplying the index by 1,000, and then the month here is just added on the end. So I'm going to have 1,001, 1,002, 1,003 for the first 3 months of the first water year, and then after that it'll be 2002, 2003. If I click on my file for this, oops, I renamed the file. Hold on. Okay, I just realized I renamed the file to all data, so that should work. Here is the all data file. So at the top, I have a comment, I have the table name and the file name, and then the fields is ID, inflow, and demand. For ID 1 through 12, I just have 0 values. But if I scroll down a little bit further, the ID is this first column here. So I have basically a combination of the array index, which is 1 in this case, plus the month, which goes up to 12. So after 12, it increases the array index up to 2, and then it increases the month from 1 up to 12. And I have just some generic data for inflow in this second column and demand in the third column. So if I wanted to go ahead and look at that, I'll go ahead and save. While I'm at it, I'm going to also do the demands. So I'm reading in the demands from that all data table. And I need to activate demands right here. Okay, let's go ahead and run the debugger. Right click and debug as. Okay. So now what we see over here in the all variables window is the demands 1, 2, and 3, and then with the inflows 1, 2, and 3. Now, if I click on console and then just click ahead to the next time step, we see that these numbers change, or it looks like the inflows change. The demands are a little bit more static, but here's the third month, the fourth month, the fifth month, the sixth month, See, we have variation in the inflow. I think the demands changed. There they go. So that's how that works. Back to the reference manual. Here is what it has to say about the future array state variables using a lookup. So that's what we were just doing. And there's an example there. And then also a future array conditional value state variable, which implements the conditional clause, the cases, and then the condition always at the end for defining your state variables with future arrays involved. Lastly, the reference manual talks about future array goal statements. So what we have here is an example. Goals are the constraints, of course. So right here, we have this array for a constraint set n SWP of size 24. So the index right here is 23. And you see that we can reference that $M symbol as well when we are creating a constraint. All right, well, that's all I had for this lesson. What we talked about was creating future variables or future array variables and constraints, and how we can basically define an array rather than just a single value, which could save us time if we were working on multiple data sets at the same time.